Hello everyone. In the last video, we saw all the ways we can declare variables in Rust. Now we will be taking a look in data types. Let's declare a variable with the name x and assign a number 100 and print it in the console. So this printed the value 100. Let's try a higher number, and that is also got printed correctly. Now we increase the number by 1 and try the same thing. And it didn't work. So what went wrong? We did the same thing like we were doing before, just with a higher number. Then why it didn't work? If you read the log carefully, it says literal out of range for I32. Here are two things that we need to understand. One is literal and the other is I32. Literal in programming means a fixed value that is written directly into the code. In our case, it is this value. And the other thing is I32, which is the data type of the variable a that we declared. Data type is the kind of a value a variable can hold, and how the computer interprets and stores that value. In our case, the declared variable a is an integer value that ranges from this to this. If you would have looked closely, you could see another note. Consider using the type U32 instead. So we can see this is another data type that the compiler is suggesting. In Rust, data types are of two types, scalar and compound. Scalar data types are the primitive data types, the most basic ones in programming language. There are four scalar data types in Rust: integer, floating point number, boolean, character. The one declared here is an integer. But wait, we never mentioned that anywhere in the code. Actually, by the value, Rust compiler inferred that this is an integer. And if we don't specify any data type for integer, then by default, the compiler considers it to be an I32 value. I stands for integer and 32 means 32-bit or 4-byte size. There are other integer sizes like I8 or I64. So in our code, if we make the data type I64, then it will start working. Similarly, if we try to assign 128 to an I8 variable, then it will throw an error, but minus 128 is in the range. I stands for a signed integer, and the range for I8 is from minus 128 to 127. U, on the other hand, stands for unsigned integer. Since unsigned, it cannot be below 0. So the range starts from 0 to 255. Actually, the range is calculated by this formula where n is the number of bits. Here you can see negative value throws error for a U8 variable. But if we make it 0, the program will run fine. This is the list of all integer data types. The last one, which is I size and U size, depends on the architecture of the processor where the program is running. My computer is using a 64-bit processor. So I size for the program running in my computer will act as an I64 variable. You have seen integer data type holding decimal values, but it can do much more. It can hold binary numbers by prefixing the number with 0 and lowercase b. Here it will print the number in decimal number system. In our case, it is 5. If it is prefixed with 0 and lowercase b, it cannot hold anything other than 0 and 1. Similarly, we can use octal numbers by prefixing with 0 and lowercase o. 302 is the decimal representation of the octal number 456. To represent a hexadecimal number, we prefix 0 and lowercase x. F64 is the hexadecimal form of 3940. Sometimes we want to organize numbers in a certain form by using a separator like comma. In Rust, we can do this by using underscore. Here you can see we have written 1 separately from the rest of the numbers to show thousands place, but it prints 1024 correctly as a whole number. This benefits programmers for readability. If we are using an ASCII character and want the bytecode of it, we can write the character in single quotes prefixed with a lowercase b. This is called a byte literal, and it will always return a value of U8 data type. Our next data type is floating point numbers. Here we have two sizes, F32 and F64. Floating point numbers are numbers which includes fractional part. So if we add fractional representation to an U8 variable, it won't work. For that, we will use F32 data type. To print fractional part, we are using the format pattern to print the decimal as well. For more precision, we can use F64 as well. Both F32 and F64 can hold both positive and negative values. Our third data type is boolean. This is very straightforward. To denote this type, we use the keyword bool. It can have only two values, either true or false. You cannot assign any other value to it, as it will throw error. The fourth and the last of scalar data type is character. A character is a basic unit to represent information. It can be a letter, number, or a symbol. Characters has to be written within single quotes and one character at a time only. More than one character representation using double quotes is called a string, which we will cover later in this series. The maximum size of the character data type is 4 bytes, representing a Unicode, which makes it capable of representing a lot more than just ASCII. You can see in the code, it is able to process any alphabet, irrespective of whether it's a lowercase or an uppercase, an integer, a special character, or symbol. Even an emoji as well, only because it can handle Unicode. Now that we have covered all 4 scalar data types, let's move on to the compound data types. There are two compound data types, tuples and arrays. Tuple is a group of variables belonging to multiple data types. Once declared, it cannot grow or shrink in size. To declare a tuple, we write comma-separated values inside opening and closing parentheses. For this special type of data, we need to use colon question mark to print in the console. We can get a specific value from the tuple by writing the variable name followed by a dot and the index of the value. Here we are using t.1 to get the second value. Tuples are zero indexed, which means it starts with index 0. We can also mention the data type of each value within a pair of parentheses similar to how we declared the values. We can also unpack a tuple into variables. This is something we have seen in the previous video. One thing to mention here that we can use underscore to denote unused variables, either by prefixing it with the name or by using only the underscore. Moving on to our last data type, which is array. Arrays are similar to tuples, except here group of multiple values are represented but all of same data type. Arrays are also zero indexed, and to get a specific value, we use the variable name followed by the index inside square brackets. Since all the values in an array are of same data type, when declaring, we only need to mention it once along with the number of values separated by a semicolon. If we need an array with all the elements having the same value, we can create it by using the shorthand. Inside the square brackets, we need to write the value and the number of elements separated by a semicolon, all inside square brackets. This single value can be of any scalar data type, integer, float, boolean, or character. So that's all the primitive data types we have in Rust. You might think, I haven't covered string yet. So how can I say that all data types are covered? Well, in this video, we have seen all the primitive data types, whereas string is not primitive and is a heap allocated, growable UTF-8 data structure. We will cover this in detail in a separate video. For now, this is all we have in this video. We'll catch you in the next one.